So it's my pleasure to give you some background information about the astrophysics side. I will not show any formulae, don't worry. First, I want to give short information, a word about myself. I'm a member of the Gesellschaft zur wissenschaftlichen Untersuchung von Parawissenschaften. That's the Society for the Investigation of Parasciences, GWUP for short. So this is what we call a skeptics society. And part of this, my engagement in this society is that I organize a series of public talks which take place actually here in this room. And Christine already gave one talk, and also Charlotte Förster gave a talk in this series. And you can watch these the videos of these talks on a YouTube channel. It's called Skeptics in the Pub Wien. Just look at it and you can follow their talks. And you can also become a member of the GWUP by following this link or with this QR code. Okay. As Christine already introduced, the moonlight does have an effect on marine and some terrestrial species. This is well proven, but at least the marine species, they live in dark places. But humans are exposed not only to light pollution outdoor, but also to artificial light. And this light pollution is often many times brighter than the light of the full moon. And to illustrate this point, I actually can refer to one of my publications, which I'm showing on the next slide. So together with two colleagues from the Institute for Astrophysics of the University of Vienna, we did measurements of the night sky brightness in two locations, one in Vienna and one 35 kilometers outside of Vienna. That's actually a quite dark observatory site. And you see the night sky brightness as a function of time over roughly a year in these two graphs. So this is the dark observatory, 35 kilometers from Vienna, and this is the average brightness for each night. And the higher the value, the darker the night sky is. And these symbols here, they illustrate the new moon. So when there's new moon, the night is very dark. And you see a nice periodic pattern at this dark place, but not so in Vienna. The light pollution is dominating, and actually the natural rhythm of the moon is hardly visible at the site of the Institute of Astrophysics in Vienna. So yeah, and even so, this is a very strong signal that interferes with the moon. And the question is if under these conditions actually entrainment is possible. And compared to other big cities, Vienna can actually be considered as a relatively dark city. The city of Vienna takes measures to reduce light pollution. And besides outdoor light pollution, there's also artificial light that we are exposed to. For example, a normal candle at a 2 meter distance has the same brightness, or the same illuminance, as it's called in physical terms, is as bright as the full moon in zenith. To put it in numbers, it's a quarter of a lux. Humans have made cave paintings more than 40,000 years ago, and they must have used artificial light for this in a controlled way, probably for many years. So already back then they were exposed to artificial light. And archaeological excavations have shown that humans have used fire for more than 1 million years in a controlled way. And this has also impacted human evolution, and I think this time frame is longer maybe long enough, but maybe the biologists can say that this is long enough to actually influence, to be evolutionary relevant. So the question is entrainment as observed in marine species actually possible under these conditions? And so this was about the light. I want also to talk about gravity and tides from the point of view of physics. I have to say that the gravity variation induced by the moon is extremely small. I'm showing here a graph from a paper by Wu and collaborators from 2019. They built an atomic interferometer which can measure gravitational acceleration extremely precisely. And they run it for about 12 days. And what you see here is the variation that is induced by the moon. And the full amplitude of this curve is 230 microgal. You don't have to care about the unit here. But to put this into perspective to everyday situation, you can compare it to the change in gravity that is induced by changing one's altitude by 74 centimeters. That's about stepping up the stairs from the bottom to the stage here, or maybe slightly more. And there are no biological effects that are reported based on such altitude changes. Why does the gravity change if you walk up the stairs? You're just further away from the center of the Earth. So the acceleration, the gravitational force that you feel from the Earth decreases slightly the higher you go up. Also, tidal forces. In my talks that I like to give to talk about the esotericism around moon, like cutting one's hair according to the moon calendar or cleaning windows or whatever, I like to make a comparison with the tidal force that the mass of my body exerts on objects in my surroundings. I make a calculation at 1 meter distance. And actually, at this distance from my body, the tidal force due to my mass is about 70,000 times higher than the tidal force of the moon on the same object. Why then do we see the tides in the ocean? It's because the oceans are so large and they react to even very tiny forces. The water flows along these forces. And that's why we have the tides, but I don't produce any noticeable tides. And also one might, or it has been put forward in the past that magnetic fields could have an effect on the life on Earth. But the moon has no large-scale magnetic field and also no ionosphere, and it orbits mostly outside Earth's magnetosphere and influences it in a negligible way. It has some tidal effect because the seawater is salty and it is conductive, so it slightly drags along the magnetic field of the Earth. In this way, it slightly changes the local magnetic field, but it's a factor of about 10,000. So the variation is a factor of 10,000 smaller than the overall magnetic field of the Earth. And also, there are solar storms that are a factor of 10 larger than this tidal effect. Okay, the bottom line, you probably already understood that I'm kind of the devil's advocate here. So moonlight is faint, but it has a proven impact on the rhythms of some species. But for humans, the question is if or how if this entrainment can really work. Gravity, tides, and magnetic fields are extremely small effects, and they can at best be measured as very sensitive instruments that are shielded from other influences, and their direct impact on human biology seems very unlikely, at least to me. but of course, I'm very open to discussion, and let's see. Thank you very much.
Okay.